Hai, Assalamualaikum warahmatullahi wabarakatuh. In this video, for group assignment MAT183, we will be presenting the topic on application of differentiation. Before we start, I would like to introduce the group members. So, the first members is myself, Muhammad Danish Daniel bin Azwan Shah, and the second member is Mujahid Alauddin bin Muhammad Zulkifli, and the third members is Nurul Alani Fatini binti Azhar. So, first of all, the introduction of application of differentiation. So, what is related rates? The related rates of change associated with two or more related quantities that are changing over time. Why we use related rates? We use related rates to determine how fast or how slow a certain quantity is changing using the rate of change of the second quantity.
Hello, hi. We move to the problem statement. So first, an 8-meter ladder is leaning against a wall. As shown in figure below, if the lower end of the ladder is pulled away from the wall at rate of 2 cm per second, how fast is the angle between the top of the ladder and the wall changing when the angle d theta divided by dt, when the angle theta is pi divided by 3 radian. Step 1, we need to write down the information. So we have ladder that equal to 8 meter, and then we have a bottom of the ladder that have been put, or we known as dx over dt equal to 0.02 meter per second, and then we have a angle theta when the wall changing, or we known as d theta over d dt, or theta equal to pi over 3. So first we have to use cos theta equal to y over 8. So as you guys can see, the wall this is a triangle. This is a triangle, and we use a Stokastov's formula to find the angle of this theta. So we have to use a cos equal to adjacent over hypotenuse. So adjacent, we don't know the value, and hypotenuse is actually 8 meter. So we elaborate it, and we have to make y as at the front of the equation. So y equal to 8 multiplied by cos theta, and then we have to use Pythagoras theorem, and this is where the last step we need to use. So we move to the next step. Next is we have to differentiate cos theta equal to y over 8. So we have to make it as a tan theta equal to x and y tan, because we have to use Stokastov's, like as you guys can see, toa tan adjacent toa is actually opposite over hypotenuse. So we have to we have to differentiate tan theta equal to x over y. So we get sec 2 theta multiply, we have to multiply d theta over dt equal to dx over dt multiplied by y minus x multiplied by dy per dt, and all of that we have to divide by y over 2. This is actually a quotient rule. We have to use separate them as x equal to u and y equal to v, like uv prime minus vu prime divided by v the power of 2. Okay, so we move to the step 3, which is there are 2 steps in the step 3. So first of all, we have to use a theory of triangle, that is cos is actually 1 over 2 and sine theta is actually sine theta equal to square root 3 over 2. So as you guys can see, y equal to 8 cos theta, and cos theta is actually 1 over 2. So we have to multiply 8 with 1 over 2, and we get 4 meter. And second, we have to this is actually where we use a Pythagoras theorem. X equal to actually the equation is actually x the power of 2 plus y the power of 2 equal to 8 the power of 2, and then we have to move the y to the right side, so we get x equal to square root 8 the power of 2 minus y the power of 2. So we get x equal to 4 square root 3 meter. Alright, so we move to the step 4. So how we find dy over dt. So dy over dt, we have to use x the power of 2 plus y the power of 2 equal to 8 the power of 2. We have to differentiate each one of them. So we get 2x multiply dx per dt plus dy multiply by dy over dt equal to 0, and we get x y we get x where the 2 go. So the 2 right here is actually we have to divide, we have to simplify the value of 2, so we get x, and then x over there, we have to separate dy over dt because we want to have the answer of dy over dt, so we have to separate them. So dy over dt equal to minus x over y multiplied by dx per dt, and then we have to substitute the value of x, which is 4 square root of 3, and y equal to 4, and dx per dt is equal to 0.02, and then we have to substitute the value of x, y and dx per dt, and we get negative 0.0346 meter per second. And we move to the last step, which is step 5.
Is the solution to a mathematical optimization problem involving a closed cylindrical container with a hemispherical lid. The problem has three main parts. First, expressing the height h in terms of the radius r. Second, deriving the total surface area of the container. Third, finding the radius r that minimizes the total surface area. Second problem solution. Part 1. Express h in terms of r. First, we use the formula for the total volume of the container. Volume total equal to volume cylinder plus volume hemisphere. Substituting it, pi r2h plus 2 over 3 pi r3 equal 45 pi. Dividing through by pi and solving for h. h equal to 45 minus 2 over 3 r3 divide r2. Simplifying further, h equal to 135 minus 2 r3 over 3 r2. So, the height h is now expressed in terms of r. Second part is derive the total surface area as. The total surface area consists of the curved surface area of the cylinder, 2 pi r(h). Second, the base area of the cylinder, pi r2. Third, the surface area of the hemisphere, 2 pi r2. Adding this together gives surface area equal 2 pi r(h) plus pi r2 plus 2 pi r2. Simplify surface area 2 pi r(h) plus 3 pi r2. Now we substitute h equal to 135 minus 2 pi r3 divide 3 r2 into the surface area. Surface area now equal to 2 pi r 135 minus 2 r3 divide 3 r2 in bracket plus 3 pi r2. Expanding and simplify, surface area equal to 90 pi over r plus 5 over 3 pi r2. This is the formula for the total surface area S. The third part is minimize the surface area S. To minimize S, we differentiate it with respect to r. As surface area equal 5 over 3 pi r2 plus 90 pi over r. The derivative ds over dr equal 10 over 3 pi r minus 90 pi over r2. We setting it ds over dr equal to 0. We solve 10 over 3 r equal 90 over r2. We rearranging 10 r3 equal to 270. r3 equal to 27. We taking the cube root, r equal to 3. Thus, the radius that minimize the surface area is r equal to 3.
So the conclusion is, we see how essential derivative rules are in the word problems that involve quantities rates of change. In fact, related rates will help us when we want to solve problems that involve two or more related quantities that are changing over time. So that's all from us. Thank you.